So, welcome to week 2. This week we're going to do the FamRPG, which is a way of seeing the flow of different people in the project. So, for example, designers don't always work in the engine or in the program itself. Sometimes the programmers work on a different program altogether where they look at numbers, look at characters, stats, etc. And in order to do that best, some of those environments already have their validation made for them. For example, on the guessing game, when we enter some data, we have to verify if that data is the type of data that we're looking for, that we can process and perhaps know what to do. Branch it, make an if statement, a conditional, something that helps us understand what the user intended to do. So that's called validation. Just like when you enter your address when you're ordering something online, you know that if they're letting you enter characters like A through Z in the phone number section or in the zip code or some other type of numerical field, that's incorrect. That would be the program helping you avoid making those mistakes. So, designers sometimes work straight up in Excel or Google Sheets. We're going to be using Google Sheets, as you will have seen from other videos in this activity. Google Sheets allows us to treat each cell like elements in an array. Either the column is an array or the row is an array. And in addition to that, since we can address or get access to every one of the elements in that column or row, we can say what kind of data is going to be present in that row. So that's what that space in Google Sheets or Microsoft Excel or Apple Numbers allows us to do. So you will, in this activity, what I'm going to show you right now is in the code, but when the whole activity includes a part that's done in Google Sheets and the part that's done here. So when you download the package that we have, I'll show you what it looks like. See, did that go over? Yep. We get zip file and it unloads or unpacks PnP1 menu. That's the project that I made where you're going to be playing. When you send us something, you should have in that zip the exe along the files that it needs to run, plus the CS files, .cs files only, not .cs project files. And in addition to that, the .csv file, which that stands for comma separated values type of sheet. I'll show you that in a second. See if you can. I hope that this shows up well. Let's see, medium icons or something. Extra large icons. Large icons, that'll do. So, if you haven't seen this before, if you don't recall it, make sure you write this in notes because future classes will expect that you already understand that without having to show that to you one more time. So, the folder that contains the entire project code base has a .sln, which stands for solution for Visual Studio, and inside that folder, or in the folder that's alongside it, there is a bin file which stands for binaries, obj for objects, which are the objects that are going to get linked so that it can create the binaries. Binaries are generally the application programs. In Linux, Mac, they don't have a .exe attached to them, but in Windows it's called a .exe, which stands for executable file. So here are the files where you're going to be writing and doing stuff, where you're doing the code. Those are the .cs ones. Generally you're going to be playing mostly with person.cs, program is where main is, and menus is an interim program that I did so that you can have some menus and see what it is. Progressively, the projects in this class get more and more optimize, as we would say. Purpose of these projects, remember, is to get something done, make sure that it works the way that it intends to, and if you can, extend it. Do something that is about your particular design insights. And this is not a game in this project. It's mostly grab data from one project, showcase it in a different project, see that it can work. Because next week, when we do the battle system, some of that data will already be implemented in there, some of the characters that you're going to be using, but you'll see how sterile the project becomes if you just let default data be what runs or plays the game correctly. So now that you could see the flow of information from Google Sheets into our project, maybe next week you'll be a little bit more enthusiastic about modifying and making that game your own based on the data that you create. This is part and parcel, as they say, about what is the typical practice of a developer. Now, you could be thinking that you're doing design, but frankly, you're not designing the games. The guessing game's already designed. If you were to do tic-tac-toe, that design already exists. You're not creating a design from scratch. However, I think designers, as they wear many hats, they find the gaps in which design is not thorough, complete, cohesive. It's a real good word. Coherent. It's another really good word. So that then the overall design feels like it doesn't have any holes to it, that people aren't going to be finding these areas of perhaps exploitation, perhaps the feeling of it's not complete. It's cool that when we play Mario Brothers, that first missing, the invisible block, is there by design, not by mistake. That's a really good thing. So that's what we're trying to do here. Find where those design areas are, and you can find them and maybe play with them yourself. So here's another thing that I want you to focus on. That .cs file is going to be found either on debug or in release folder, this is the naming convention that I want you to use for the .csv file. Acosta Keva, not my name, of course, your name, _fam, and .csv. The project will create that for you in a test generic file. You have to go here and edit by clicking just one time on top of the file once it's selected and changing the name there. Okay? That would be found in release if you're building a release, but we're mainly staying in debug so that we can debug the game. So this is one of the files that you're going to grab and you're going to package with the rest of the stuff. Trust that you are able to do those Windows types of operations. Let's go into the actual code. See what this tells us. Double click on the solution. Right now I'm using Visual Studio 2017, but if you were to do it in 2019, I have both, so you can send the package to me. It'll open, and it'll open like this. They both look very similar. Obviously I'm using a dark theme, so you can use all kinds of different themes that you can implement so that it makes your eyes feel a little bit more rested. It used to be a long time ago that people would know that it was Full Sail students because they had the dark theme in there. So this is a good time to get some coffee or some water. Actually, water helps more. I have some orange soda right here, and I'm going to try to speak kind of fast about some things because I want to show you all the things that the project has in addition to making it work and making the project work for you. Now, mind you, some of the things where I'm going to show you to highlight, that's going to be up to you to customize. you're also required to deliver a set of screenshots of how the project looks. Now, that's so that I can see how interested you are in creating files or images that display your data. I know it's going to be text and just color text, or background colors with color text on top of it, so it looks kind of funky and old school. But I think I've mentioned it before, and I'll mention it forever. One of my favorite games is called Candy Box. It's online. You can find it online. There's two, Candy Box 2 and Candy Box 1. I'm playing mostly Candy Box 1 because it's the most simple and surprising to me in my mind. So the reason why I think it's really cool, games like Dwarf Fortress also do this, the original one, not the one that they're proposing with new graphics nor mods or anything like that, is using ASCII art, meaning just characters that to display the data. I'm fond of that because it lets me know that I can do it without having to worry about whether the aesthetics are pleasing before I understand the design of the project. Much like when we're making all kinds of prototypes, we probably default to using things that are cheap and available, like beans or pennies or whatever that you can find that you can have multiple counters for, so that it can be versatile without having to break the bank. So let's see where this goes. Let's start at the start with program. Let's first run it. See what runs. You press Control Save, Control 5, and it should bring up a menu that lets you select a person, and you have 4 different people to select from, just like from the RPG. This is unnecessary here. The antivirus is checking my own project. Well, let's cross our fingers. So, by the way, that's a check on the exe that's running, not that there's a problem with my computer with viruses. My computer does not have a virus. Also, don't give me one. So we have 1, select person. We have 4 people to select from. We select the first one. It shows you a list of entries or things that you can modify, which is the data that each one of the classes that we're going to eventually discuss here. We did that on the object-oriented programming lecture, which is during the first week on Thursday. One of the details for that character is the name. If we press 0, it'll ask you enter a person's name, and that person's name will be Goku, and that's it. We can press space to view that person's all details, and it shows Goku and all the other stats. Now, we have to validate the data. I am not aware of Goku's actual age, but I know that if it was like the data that's over on the FamRPG Google Sheet, the maximum is 18, because we're doing some stats a la Dungeons and Dragons. So if we pressed space, it'll go clear the menu. Press escape, it'll go back to the previous menu. Press 1, again go to 1, press space, we'll see that Goku was stored. Now this data is not going to be stored once we quit out of the project. It's only while it's in runtime. So we're going to edit the strength, and we're going to say strength 2. And that amount's going to be 18. I wish I could be more, but we press space. Now we say we have Goku 18, and we can continue to modify the rest. I'm not going to detail every single one of them. I'm going to trust that a lot of that data works. You can test it yourself and see if there are any issues. Just let me know. Let us know. Okay, so we're back to the first menu. We can also display that person. We can say, well, which one do we want to display? 1. And it'll show Goku right there. See how it's right after I press 1 and it dumps it off like that? That's what we're going to fix. We're going to show how to display data differently. Now, within the console, background, console, foreground color, all those details, but it's a matter of recognizing that the data that's available in one project then needs to be presented differently during runtime with the project that we're making. That's a really cool thing. It's almost like you can play Tetris in your head or Tetris in paper on gridded sheets, and then make it in the computer with text boxes or with very simple line graphics. That's part of demonstrating the type of data that's available in the Tetris game. I didn't know this until very recently years ago, but that Tetris, in order to be official Tetris project, you have to have the correct amount of Tetris pieces available on a reoccurring bag of pieces. So these things have been formalized. The colors of the different pieces, the T, the Z, the N, however people call them, those are also color coded to the Tetris guidelines. It's a very well documented set of standards for an official Tetris project. So we can also say export all persons to file. When I press 4, enter the name of the file to export, let's say Goku Fam. Press enter, and now we can quit the program. Press Q. Or escape. Yeah, escape. All those validation things, I'm going to leave them up to you. You can show them. Let's see what happens when we go to debug. Now we have the PnP.exe file. Okay, that's important for us. We need that file. We can also click on Goku Fam, and you'll see that Goku, the file that was the first one that we had, which was Goku and then strength 18, was there. We would have added Trunks, Vegeta, etc. But I hope that you can follow along with making that file. The reason we create that file is because then we store that information, and we're treating this file that we're using here as an editor, not just from Google Sheets but also here. These programs tend to be made inside the engine that you're using, or someone else makes that tool. That's the technical designer's department to create those tools for you. They're honestly the first line of defense for bugs and for good obviously in an electronic game department, good solid consistency. Obviously there are technical designers for other areas of other games. For example, if we're making some kind of toy, the technical designer is also the person that's guaranteeing that the 3D print or something like that has a good pipeline of making the assets in Maya or anywhere else, etc. Anyway, let's discuss the code. Let's go to the program first. So I'm going to introduce a couple concepts here. I'm sure that you've heard of the word static before. So the projects that we make here on Visual Studio C#, they require the first entry into the program. When we double click on the exe, it looks for this file and the called program or something that's at the root start of that project. And it should have a static function called main that returns nothing, because it returns just straight up to Windows. Windows already has all the information that it needs. But it's got to be called main. It's got to be called like this. Okay? Now, that static keyword means, imagine if you were making a schematic, some type of architect's blueprint for a house. Okay? A house, in definition only, obviously needs a door. So all houses will have doors, technically, entrances, if you want to be more accurate into what all houses need. Obviously, a building that has just walls and no entry, well, We can't be in there to know what's going on. So technically, every house for humans is going to need an entrance. So entrance is a statically defined concept or attribute for that class. No matter who, if I said I'm making my house and on the blueprint, and someone actually goes to the house and sees the house, without, even with blindfolds, they will ask, where's the entrance? I need the attribute for a house called entrance. What do you call your main door? I could have called that variable something different. Could have called it door, could have called front door, could have called it, I don't know, entryway. But the concept exists in every version of what we define as a house. For our program, every program that starts has to have an entryway called main. And because that class is static, everything that it accesses also should be static. Because as I keep researching and going into that concept of the entryway or the static thing, other things need to also be presently defined. That also allows us that when we instantiate a version of the class, every instance of that class will have the same data point, data access to that static, because it's defined as static. So let's say that we had an int called current menu, or we can have an int called counter. That int can be defined inside here without it being static because it's locally defined to that function. But if it's defined elsewhere outside of it, it has to be static so that whenever Windows calls main, it will be able to access any of the other things as if they were created and instanced. I hope that somehow, as we discuss this code more, you feel more comfortable with asking about this concept. This whole lecture is not about that concept, by the way. It's just something that's important. So I left this here. It's a good set of commands so that you know how to write for currency, decimal, scientific, fixed point, general, numbers, percents. So it displays things as percent depending on how you format and enter this into your. See, notice this is the first parameter on the right line command, but this :C is what changes the format to display as if it was money. Okay, it adds those details for you. So let's see. Here's another concept called the blackboard. You'll see this in shader languages and places where there's a whole area. It's basically like scratch paper. It's as if I had this piece of paper right here, and in this piece of scratch paper is the common scratch paper. It's like it's called blackboard as if it was a blackboard, but it's more like a kitchen fridge note where everybody goes there and sees, oh yeah, we have that, we have to go get that. We know stuff that is common for everybody. So one of the things that we're going to use is the menu class or the people that exist that we're going to define. Let's do that for a second just so that we can keep track to the object-oriented stuff. So we have a class called, inside the namespace PnP1, which is PnP1 menu, which is what ties all these files together or allows us to access other definitions, class definitions in there. So inside the file called person, we have, start zooming in so you can see here, we have what I'm calling a base class. Think of base classes as the most generic version of things that tie a lot of subclasses together. For example, I'm a human. Humans are mammals. So that means that all the things that apply to mammals apply to me. Now, that's not the same thing as all the things that apply to me apply to all mammals. For example, as a human, I do have a car. Not all humans have cars, but I have the ability to have a car. I don't think a dog has the ability to have a car. Maybe there's a law somewhere that allows for it, but that's how we're going to look at what base classes are. Humans are mammals, so therefore the base class for human is mammal if I were to define a class called mammal. Now, base classes are used to define a whole bunch of really interesting things that are then subsequently going to be accessed by the child classes. So on a base class, you might define movement as all things that are going to derive from it are going to have that natural variable, member variable for that class called movement. And then every other subsequent class that derives from that base class can say, well, I'm from that base class, so therefore I can move. Maybe I can move 0 amount, but I can move 0 amount. The number that you add so that you can have some definition can be up to each one of the things that you create. So that's a cool thing about classes, how we break this down. I did this in the other video to explain it a little bit more, and we'll continue to press on through the week, especially during lecture, to help you with some concepts that we're wanting you to know. Now, as you know, for class object-oriented stuff, encapsulation, abstraction, inheritance, and polymorphism, the definition, or what a class does, which is contains member variables here. This one's set to private because it doesn't say anything, so we assume that it says private right here. And private means that only classes like it or that derive from it can access it. For example, I was thinking about this subject, and you guys know me by Kayvon, but that might not be my name as it's supposed to be written out. It is, but my point is I introduced myself to you guys as Kayvon Acosta, but the access to changing my name is only up to me and whatever government I'm registered into. So if I wanted to change my name to, let's say, Bob, then I would have to, it's a private detail for me that I go and change. However, nickname, not everybody has a nickname, but everybody knows how everybody is called. So I can tell you, well, my nickname for you would be Kayvon, though my private version of the name is something that I only have access to. I don't know what, for example, Cher, Seal. I know Prince's name is Prince. That's from birth. But Madonna, all people that have these single names, Bono. Who else? I'm missing so many, and I'm kind of running through the list of the most super famous single name. But if you have your theater name or whatever, they all have unique names, but that's not their official name. There are other details and data that is private that then other people can access. So if I wanted to give other people access to that name, for example, here's a person class that inherits from base class and has a name. I set it to public so that we wouldn't really change or play with too much of the differences between the types of encapsulation that we have in this class. But I could definitely make this private and then give other people access to that name by having a function that displays that data. Now, notice all the different functions that I have, member methods that I have in this class here. These are them. This person class has 5 methods, 3 constructors. You can have as many constructors as you want in C#, and 1 action to override from the base class, meaning that the base class has a version of that function, and then we say, here, make it better. It's almost as if your father or your mother have a version of what it is that they do, and you, because you inherit from them, can do it, but you can specify it further. You're a little bit better at doing something than they are. So that's the point of these virtual member methods, or adding that keyword here, so that then you can go here and override it. For example, let's say that your mom is a musician and she showed you how to play music like she does, but then you go and override or improve or add different ways in which you play it. That means that any child object can be doing things differently than their parent classes. So if I wanted to give access to this member variable alone, I could say something like this: public. They need to be public so that you can give access to other classes, and this is the way that we get that information from another class. String, or give access to that information to another class. It's going to return, so first, the protection, second, the type of the return type, the name, get name, the input parameters, and I don't need any input parameters, but I do have to return name, which is this member variable right here. So anybody that calls get name will be able to access it. This is not code that you have, but I'm going to show you that, how you would have done that. Additionally, you can change that data. By the way, you can say set name, not even return it. When you're setting, you don't need to return anything. You want it to change in one way, so return nothing, return void. And now we're going to say name is equal to, let's go write it in here, a string that's a name. I write underscore name so that I can keep track that that's only local to a function. I never write any other variables or variable names with that underscore unless I know that it's a parameter from a function call. So name is equal to underscore name. Now whenever I write, let's say that when I'm calling that function set name, I put here Bob. Well, now Bob will be my name, because the name, which was Kayvon, I went to the government, paid for whatever, and now change that to whatever's inside of there. That's if I was calling it. I'm not calling it from here, right here, because this is the definition of functions or classes definition. So all of this is to be deleted, so I hope that you understand that part. Okay. So we've explained in lecture what this type of base class does. It's like writing mammal, and here this one person is human. But in game terms, they're a little bit more generic so that we can use them across different games. So let's say that you have characters, and characters inherit from base classes. Okay? And characters can be players or can be NPCs. So players could inherit from character, or NPCs can also inherit from character. Now players allow for input, NPC allows for AI, right? So on players, we would be writing a different set of inputs, and on NPCs, would be writing a different set of functions that allow it to process AI. That's the long and short of how that bit works, and why we're calling things generic and use things like that. For example, in this game, or not game, but program, here the program, I have a person called P1. P1 typically is a player 1 and whatever. We're not going to use that because it doesn't have any interactivity that's game-like, but it is a tool that we can use. Imagine that you had a million records, okay? Meaning a million different characters or a million different people and accounts. You'd have this in huge games like MMOs and things like that. Or accounts from Xbox Live, PlayStation Network, Steam, etc. So if you were to have a program that all it does is guarantees that nobody's entered, let's say, their name in all caps, it would be very cumbersome to just get all that data and have a person evaluate that. So you create a tool. C# is a place where you can do those tools using other programs that are online, which are very useful because they have access to databases and things like that. You can use Python, you can use JavaScript, Java, etc. But know that you have right at your fingertips a very powerful tool in Visual Studio and C#. So databases, you may have heard about them. Databases are a base of data. Think of Excel or spreadsheets and those kinds of programs, but it can be millions and millions and millions of records, and it has some really good lingo in the programming that you do with databases so that you can have, for example, matchmaking. When you are, let's say that we all have records or our accounts for any matchmaking service like Xbox Live, and I said I wanted to play casual. Well, the way that the request goes is I want to set up a game where only casual players are going to play the game. It looks through every person that has casual interests or that let's say their gamer score is really low, so it's basically really introductory type of people, and it creates a subset of people that then match other criteria so that you can have a casual type of experience. So that's why databases and keeping track of this data is really cool, and paying attention to tools like this then allows you to communicate with other people in your team. Hey, we need a tool that guarantees for this type of process. Anyway, many ways. I already ran the program and I didn't like how it shows the people. Let's see what data the people have that we can keep track of. Notice that it has int for age, because there's no such thing as 4.5 in our world. You're either 4 or 5. Literally, I have a picture evidence of a place that the speed limit is 4.5 miles per hour. I don't know how, maybe it was a prank, but that exists. So, but this person here, when it displays some data, we go to display data. That's a function that we call in order to display something. Notice that it's very generic. It says black and gray, which is the typical default. Right now, this background is gray. Well, not when I highlight it, right? But in this line 107, where it says toString, the background of the T or the S, the R, the I, and the NG, the background is black, and the foreground is, I think, might be a grayish. Let's see what happens when we run it. No, thank you. There. Yeah, it's gray. Let's see, is it just the same type of color? It's gray. I think the one in Windows on Visual Studio is a little bit lighter. But here it's background. Right now it's background white and foreground gray. But the inverse of that would be black and gray foreground. So if I were to change this to, let's say, yellow, save it, run it, display person 2, press 1. Now notice that all the attributes change there, and I press something else and it'll keep doing that until it finds another block of code that says console.background color equals console color dot black, and the same with the foreground dot gray. So up until here everything was printing without having checked for a change in color. So let's quit out of here. So that already helps out a lot. We can also say let's print the name, and notice that I'm making one string line concatenating everything, meaning that I have a string called string line, starts empty, and then I said it's equal to name plus a comma. And then I have a for loop. This is an entry control for loop, like on the menus. I think I have a while here. While you're doing this, press escape. Chart 27 is escape, so that it quits there. Entry control loop means that you loop, but you first check a condition at the top of the entry of that loop. If that condition is true, then it allows it to loop. While that in other words, while or for this many times, or etc. The initial condition, the entryway, is what allows it to loop. It might not even loop, given that a condition may have changed that doesn't allow it to loop. That's not the same thing with a do while, which is an exit control loop, which does the thing first and then exits. We're going to discuss that in class further in the following weeks. So we have, let's go back to the person, which is where we're really wanting to focus on. Since each person on the data class that we have here, notice that the attributes are an array, and I define them the size of 6. Now, this may give you an error if you don't know the people when you create them. So notice that we knew the array when we created default. Use the default constructor, the one that we created, but we still needed to have an array initialized or newed, instantiated by int size 6 from 0 to 5, so that it could be accessed and have it be defined and you don't get a null reference error. So what we're saying with another one of these constructors, or when we're displaying the data, is saying for int j, I, j, k are the typical x, y, z's of loops, of for loops. I usually stands for iteration, incrementer, iterator, index, and so on. So it goes from 0 to attributes.length. The attributes.length for this one would return 6. So we can check, hey, is 5 less than 6? Yes. Do this thing, which is plus equal. That's concatenate. Just like we concatenated here the name to a comma, we can say name comma that already exists plus equals whatever is in attributes plus equals comma. And that way we don't have to make this line here, we can put it over here, but just so you can see step by step. Every other one of these is a plus equal plus equal. By the way, if you press and hold Alt when you drag down here, it'll let you select this, and you can this messes it up, but it'll allow you to play with and copy stuff a little bit more efficiently. So we look for program current person wait dot to string. That means that this line here is aware of that class called program, which has a static current person here. We can access it by just calling program dot current person. a current person like we have it defined here. What is current person? That's the name of the instance of that class. Of which class? Person. Person is the same as any one of these here. So that means that current person, which is a new person when we instantiate it, can call that current person's dot weight. Do I have a dot weight? Yes, I do. That means that current person also has that. Then we right line the string and we rekey. We can also just right after this do a console dot write line, and it'll write a line, right? And copy it like here. I should copy here and everywhere. Or no, it wouldn't be console write line. Maybe we can say print every single one of these in there, you see? And it'll print everything up into that point. Right now it's going to look really ugly. You're going to see. Save it, run it. This will change every time that we call the display person. Press 1, and press space. See, it keeps printing. That's broken. Okay. So, we want to undo all this. What we want to do is right here put \n. Instead of comma, maybe \n. Let's see what, save it, run it, what happens. Display person. And now, up until that point, then it started to write every one of these other ones that we clicked on there. But the best thing would be if every time that we do that, when we print one of these, we say the colors are different. Maybe to illustrate something different, something better, something cool. Say blue, and from there on in everything's gonna be blue and white. For age, we change the console color for, what is this, let's say AC is red, and then back to, let's say HP is green. Now we're using colors. Best thing is not to use colors. It's actually to introduce what we're printing. We can say for this, because color, there's a lot of color blindness in males, especially. About 10% of males are colorblind, and females are about 1%. So that's a significant difference between the two. And or at least with the typical populations that play our games, we want everybody to play our games. So defaulting with color, while it's great information if you can see it, if you can't, then you're confusing people. So what we do is we use, you'll notice that there's a lot of colorblind modes everywhere in a lot of games, especially puzzle games. And for that, what we do is we use symbols to represent things. You can't use a red cross though for games, because that is both a registered trademark or copywritten, especially for helping situations, so that you don't have different competing companies using something that's so visible and so understood as health. the inverse is fine, and it's a flag too. So one of the things that we can do is when we have here the backslash n, we can add a, instead of adding to it, we can just print it. Like we had here when we said console dot write line string line okay, that'll print all those things right there. And but what we don't want to do is concatenate it if we're going to do it like that, because then we can print it, add to it, but once we, instead of adding to it, that means that it's not going to concatenate it, it's just going to replace it. So up until here everything's concatenated, but then we blocked it, and then it'll concatenate the backslash n so that it's a new line, and then it'll print it. So let's add the same thing here. Let's change this string line wherever we're printing it. And all these attributes are going to have a different, first is gray. You know what, let's say, so it looks cool, say magenta, and the foreground is going to be black, and string name is that. Going to print that, and then here that's a number, so we can convert it to string and save it, run it. But we are going to, right before between these lines here, going to change the attributes to be, let's say, background red and the foreground yellow. Okay, I don't know what this looks like. Let's see. Control save it, Control S, Control F5, and AVG. I'm not happy about that. 2, display, and now we have numbers like this. Now we can press space and go out of here and go select person, press 1, enter name by pressing 0, and we're going to say the person's name is going to be Jack. Enter and press space, and now we have Jack, and the numbers start to appear there. Very basic, but it's about seeing everybody have different formats. You can make little boxes, you can make menus, you can make anything you want inside a display menu. I want you to have fun with that. I used to have a lot of fun making those menus, I really did. So now we're going to export all file or persons to file. Let's keep playing with that one person. Age 1, let's say the age is 22, and the person's strength is 15, and enter the weight. The weight is going to be 175. And notice that the amount of information is there, and we press escape, export all persons to file. Let's say new test, and we escape. Now we go to the bin, see what's there, new test, Jack, all the details are there. Of course the we're not going to see the colors here because this is just a preview file. This is just a text file. You can open it with Notepad. as you'll see right here. Anyway, now let's play with other elements in the menu. In the menu here, we had press 1 to enter a number from 1 to 4 to select a person. Press 2 to display a person. Notice that we have 3 and 4. 3 does nothing. And we also have 5, which is something that I want you to play with in terms of the metrics and other averages that we can do. So let's uncomment this. Control K, Control U. And let's say that what I want to do is to change the metric units, or the type of units that we select, to metric. Each one of these characters stores a value in integer form, but when I display it, I can display it however I want. I can say that this class, or the menu class, okay, has some, notice menu options has no data, just functions. We can say display metric, a bool display in metric, or let's say metric units, and equals false. Some games, their strength is a percentage, so that would be a value between 0 or negative 1 to 1. In Dungeons and Dragons and Roll20 and all those types of games, it's a factor of 18, although some people use just 20. So when I press this function, this data here, let's say that I press 5. I want in metric, or metric, to be the opposite of metric units. So this allows us to toggle. Okay? So if it was false, and this replaces this on the right side, says get me what metric units holds. Metric units returns false. If I say that not operation of false, what's the opposite of false? True. Okay, then now this whole thing would be not false, which equals a true, which is what we're going to store here. If then it was true, it would be not true, which is the equivalent to false, and it stores it on that side. So that's all the 5 does. Also, we have to say switching to metrics. Switching dot right line. So switching unit types. We can say set can always say if metric units equals true, instead of right line, we're gonna just say right. I'm gonna say process that first and then display what it is now, because every time you press it, you expect that it would have already occurred. Set to well, if metric unit is true, I'm going to continue that line to say console.write trick. We have an else that we can take advantage of. and say Imperial. Let's see what happens. Control save it, run it. Thank you, AVG. You're not helping out. Oh, we're not displaying that menu just yet. That's because it's not shown in the menu. It does work. If I press F5, it says it, but it just doesn't clear it. It's switching it right there. So we have to do the typical trick here of read key. So it waits there. Save. And now we have to look at the menu of what shows. See how we don't have 5 to switching units? Read file. We're not reading any files. That's not going to be available. So let's say we want the number to be 7. Yeah, let's make it 7. Unit type switch or toggle. So now if we press 7, well, we already checked that, captured that information here, check what key chart it is, and evaluate it. So we have it at 2, 3, 4, 5. We just change the number here to 7. That's it. We save it, we run it. That information is there. Press 7. It says switching unit types. Currently set to metric. Press space. Set to metric. Not displaying it, but I could if I wanted to. Press 7. Now it's set to imperial. Keeps toggling and going back and forth. See? Okay. Where do we store that information? That information is stored in the menu options, which is part of the program, which is a static. That means that I can access it anywhere by calling program.menuOptions or menu class. So if I am on person and I'm trying to display something and I want to display it in standard units or metric units, I say, well, what am I going to display? The attributes to string, that's the value. But I may want to convert it first and then make it to string. So for example, I would say if program dot menu class dot metric units is equal to metric. Okay? No, it's actually true. True. Then what I'm going to do is say the string line is going to be equal to, if it's a metric units value of percentage, I would say the actual attribute, which is up to here, divided by 18, because that's the maximum that we have, right? Now this has to all return a string, but we first have to convert that process here to float. So we can get a dot to string in there, and that'll fix that. So let's see what happens when we else, right? Just do that. Save it, run it. Display person. 1. Metric units, or imperial units. I guess they're 0% because there's nothing in there. So we have to enter some data there. So press space, select person, 1. Let's play with strength, and let's say it's 18. We're expecting a 1 somewhere if it's set to metric units. So let's display a person. 1 to 4. Let's press 1. It says 18. That means it's an imperial. So escape. Oh, have to do that again. 1, 1, 2, 18. It's right here. Just press space. See, it's 18. And now we're here, and we're going to switch the units. It's now set to metric. And now we're going to display it. Press 2, press 1. And now it says 1 because it's 18 divided by 18 would be 1. Hope you understand what's going on. So that helps the display of that part of it. The other thing that we want to do is when we press the let's sum the numbers. When I press sum numbers, I want to call a function that returns. I have to make a function on the person and call that function. So let's go here and create an actual switch statement to get there. Switches are, notice that every time that we add a switch, we extend a little bit of that. So we can just call a function that when we check for case 6, we can call, what do we want to do? Sum the data for all the different characters, right? So let's make a function for right here. Not create person menu, but it's public. Yeah, let's return an int of sum person. Let's just do attributes right now. Okay. Where do you know what the current character is? I think. Attribute counter is equal to 0. We're started there, and then we're going to return that attribute counter for that one person. We're going to first do the same code that we have here to select which character. Okay, this is what we do on 2. We're going to select this. Which character are we going to select? You know, we have that here. First, we're going to grab or console.write enter number from 1 to 4. That allows us to select one of the characters, and then we're going to make a selection that selects 1, 2, 3, or 4 as the characters that we're going to get. And so we can copy that part, go here into 6, and press. That allows us to select which character we're going to sum the attributes for. But we're going to write the rest of the code. So once we know that it's the one person, we're going to here we say switch depending on which one the person selected. Switch here depending on selection. This evaluates an int, and we say if it's 0, if it's 1, if it's 2, or if it's 3. Key chart. I think I did persons 1, 2, 3, and 4. Either way, we can test it. See what happens. We have to switch this from 1 to 4. It depends on which character we get. So we now say the program current person, which is like a placeholder for which one we're going to use. We've selected this, and now we're going to call in some person attack. We're going to attributes. So we're going to say we're going to receive a person underscore p, and now we're going to go and sum them up. That's all. A for loop. You press 4 and tab, and it'll autocomplete all of that. And then the length is underscore p dot. We know that they have attributes. Dot length. And now we're going to say attribute counter plus equals. It's already at 0. The underscore p dot attributes sub I. I is the iterator, the index of every one of these elements in an array. So that's going to sum them up, and it's going to return it. It's going to add it and return it. And we can say here on 6, we say console.write right line. We have to add one of these console read key so that it stops right there. Sum of attributes for, since we already know what current person it is, we're going to write the name of that person. And we can say comma, the first one, and is parentheses 1. This is from your notes from previous classes. So sum of attributes for sub-0 is going to be, that's the name that I want, so it would be program dot current person. I'm writing this one line down. You can always do this so long as you're not breaking and adding other characters to the leftmost of it. Okay, so it's important to know where you press enter. I'm writing it after a comma right here, which is absolutely fine, but it's just for legibility. If I wasn't, I would do it here, and it's one line. So the current person's dot name, and another comma for the actual sum, and we're going to inline call a function. That inline code is to simply call this function we made right here, sum person attribute person whatever. And I'm going to put that in parentheses, sum person attribute program. Same thing here up until, well, actually here. Program dot current person. That's what we're going to pass in, and to string. Here. Actually, I can just call it like that. This is the function right here, which we pass in the parameter that it needs, which is a person. It calls that first, returns right there, and then calls the toString and converts it into a string. Save it, run it. Okay, so some numbers, we press 6, and we're going to press number 1, and the number is 0. We don't have a name for that person either, so, okay, select person, press 1, we're going to go press 0 and say Jane. And 2, strength, 10. Age, 70. Charisma, 11. So right now it'd be 10 plus 11, 21. Constitution, it's going to be a very strong, or her fortitude is going to be great at 70. It's going to be 16. So let's see where we go back to. Display a person's details. 1, we get Jane. And the numbers are going to be, so far, 26, 37. Okay? Now we're going to sum numbers. 6. And it didn't print that because I didn't write the name. Did it save that? Let's see. That's because when we entered the person, we just went straight into P1 display data. And we just went straight into that. So let's just grab this is how we fix this. We call this function right here, right now. Param.p1. Oh, because we put it in Blackboard. Okay. Yeah. Not in program, just Blackboard. .p1. And the same thing here. You're going to see this concept used later where we're storing it to current person is equal to Blackboard P1. Oh, I know. That was a bug. That was a mistake on entry for me. Let's see if that's what was going on. I pressed 0. I pressed 1, but 1 was not the one that I entered. I save it, run it. Okay. So 1, select person. The person's going to be 1. Okay. Same details. Jane. 2, strength. 10. 1, age, 70. Constitution, 16. What was the other attribute that I had? Let's say wisdom 11. Okay. Press space. All those details are there. Okay. Now I press some numbers. It entered it in 0, but it's at 1. So now let's try and do the values person 2 and Paul. Strength 10. 3. 11. Paul 10, 11. Okay. Debugging is something else here. Well, let's just copy this line right here in each and every one of these. Instead of current person, we're just going to put Blackboard P1. I wish I could get that differently right now, but I can't. Here's a way of testing it, though. When we're trying to implement these catch-alls, like the current person is a person that we selected from the Blackboard, we want to know if this is the current person here, and we're going to display that person's name anyway. So I'm going to say program dot current person dot display data. Okay, and we're going to go here, press that line over right next to the left of the numbers, and we're going to debug it. The way we do that is by pressing F5 or start. And it'll get here. As soon as it gets here, we're going to say this one's going to be 1, this is 2, and this is 3, this is 4. But it shouldn't be selection of 1, 2, 3, and 4. It should be characters 1, 2, and 3, and 4. That's really what's going on here. And since this one's already defined, it should be 2, 3, and 4. Save it, run it. 6. Now it's calling that. Okay, so I know that that's happening. Select person, person 1. We're going to enter. Whoa, there we go. That's the AVG is done. 1. Select person 1. Name John. Age, or let's say strength 12. 7. Charisma 18. Wisdom 14. Okay. Now we're going to sum the numbers and press 1. Gives me the numbers, and the sum of attributes for John is 44. Okay, now that works. That's what's going on. What was going on was that this number here was 0, and when you enter a number, key char might be 1,500 for all the different characters that you can enter. But the computer has different types to represent the data. So when I press the character 1 is actually number 47, I think, 48. And that would be the number that I have to check. So instead I say, hey, give me the character 1, convert it to this actual number, and see if that number that's on selection, which is an integer, is the same as that one. So I press 1, which would be 48. With 48, we check it here, and that's how it goes. ASCII character tables, look those things up. It's pretty interesting. Anyway, this will work for the sum. What's an average? Well, that's up to you to calculate it. I'm going to let you uncomment this, copy the same thing, make a function that's here for the average. All you have to do is add it and subtract and divide it by the number of entries that you have. These numbers should be similar to the ones that you have in Excel anyway. So we've done the metric units. We've done the sum. I'm going to let you do the averages and figure that out. I showed you how to do display of data. I talked a little bit about classes and stuff like that. Showed you what files to have and what to export, what to package, what to upload. The goal here is to see the holistic picture of, I have one project, someone's keeping some data over here. I'm going to create a tool that allows me to have that data validated or understood, or as in, imagine that. But let's say that we have data metrics scientists that are doing the data analysis. They're not working with any of our, not working in Unity, on Unreal or whatever. So the holistic picture is seeing that they can work some data, balance it, do the systems types of calculations. We get them, we then enter them into the kind of code that we want, guaranteeing that there are no problems, issues with the data, and then we test it when we're playtesting and playing. Okay, I'm asking you to do a family so that you can maybe consider data in a meaningful way, not just what's an orc and what's a hobgoblin over here and what's Mario's strength statistic. If you think of perhaps a member in your family that you know is strong, now you have a name, you can look at other features that they have and start creating a character that's at least comparable to you. It's an interesting way of thinking. I hope that you value that. Alright, with that, I'm going to leave you to the rest of the week completing these assignments and activities. Please have as much fun as you can and contact us earlier in the week the better, during office hours. See how we can help you gain some insights that'll help you complete this activity. Alright, this is going to be 1 hour and 30 minutes, 45 minutes in double speed, which is my preferred watching method for me, about me. Alright, take care, peace, have a good time.